Hey mathematicians, welcome back. We're going to be talking about graphing inequalities on a graph today. If you have your calculator, that might help, but otherwise we're going to spend most of the time graphing these by hand today. So without any further ado, make sure you got the notes, and if you don't have the notes, you can always do this in a notebook, sketching things out, but let's get started. So a linear inequality in two variables is basically it's a graph of a line that covers a range of values in the form y is greater than or less than or greater than or equal to or less than or equal to mx plus b. I'm going to erase all those and just put a circle to represent the missing symbols just so that we don't take up all of the room that we have. And it's going to cover that range by shading the coordinate plane. So we're going to have a lot of possible answers, infinite possible answers, all represented by shading the coordinate plane. The boundary line is the graph of y equals mx plus b, and is either dashed or solid. We're going to talk about whether it would be dashed or solid here in just a second based on the signs that are used in the equation, but that's the definition of boundary line. We're going to use the greater than, less than symbols to decide whether to shade and whether it's solid or dashed. Where to shade, we're shading every time. So, if it is greater than or equal to, we have a solid normal line, and then we shade above the line. And you're going to see what above the line means here in a minute. Greater than is a dashed line but shaded above it. Less than or equal to is a solid line shaded below the line. And less than is a dashed line shaded below the line. We're going to be referring to this table a lot, so please, please, please make sure you get this part down. This is one of the most important notes you can have for this section. One of the things that it helps me remember is that is the equal to sign, but I think of it as a solid line, and that's how we know that the line is solid. So let's start with one that's already in y equals mx plus b form. We're going to graph this by starting down 4, because that is the y-intercept. We're going to get our second point from using the slope. Slope is 2 over 1. We're going to go up 2, right 1. This is graphed by halves right now. And we can do it again. We can go up to right 1. And then I have to ask myself, is this line dashed or solid? We were just talking about it. If it's got the or equal to, then the line is going to be solid. So we're going to graph a solid line. Mine's probably not going to be perfect because I don't have a ruler right now, but this is about right. And then we have to say, okay, where am I shading? So the symbol is greater than, and we need to shade above the line. And the best way to figure out where above the line is, I kind of put like a little perpendicular line right there. You don't have to draw it. But the one that's pointing up is where we shade. So above the line is going to be this way, and we will shade the part of the graph that is above the line. So all of the points that are in this chunk and infinitely on, all those points satisfy the inequality where 2 times the x value minus 4 is less than or equal to the y value. The y value is greater than or equal to the x value plugged into the 2x minus 4. That is what this represents. The blue is the points that work. The unshaded parts are the points that don't work. And And that's how this goes. That was our first one. Let's take another one. Oh, looks like we have this one that's in the wrong form. So our very first step is to go from standard form into slope intersection form. So I've got negative 2x minus 3y is less than 6. I need to add the 2x. I always put that first. Because it's mx plus b. I need to divide by negative 3. And it's an inequality. So when I divide by a negative, the sign flips. Then I've got negative 2/3 x, and I've got minus 2. Steps are going to be the same. We graph the boundary line. Y-intercept is 0, negative 2. M is negative 2 over 3, so we're going to go down 2. Then we're going to go down 2, right 3. And we could do it again, down 2, right 3. We could go backwards. We could go up to left 3, up to left 3. And now I need to decide based on the equation. Going all the way back up here, there's no equal line, so it is dashed. We are dashing. Remember, lines go on forever. Yep, put my arrows there. Lines go on forever. This is a greater than problem, so we are going to shade above the line. Get that in. That color doesn't matter for you guys. I just, for a visual, I'm going to use the blue again. Everything here and on forever up satisfies the equation. And we've answered everything for this question. We've graphed the whole inequality. So sometimes there are special types of inequalities. We have vertical lines. Vertical line when we have x equals a number, like x equals 2, would be a vertical line at an x value of 2. And horizontal lines are y equals a number, like y equals negative 3. That would mean we would go down 3 on the y-axis and draw a horizontal line. So let's look at a couple of inequalities because they have special rules when this happens. Okay, so we are going to graph y is less than 4. First we have to decide is it vertical or horizontal, so I go back. Y's are horizontal, so it is horizontal. We got to plot a point at 4. They said y equals 4. Let's see if I can do this. On the y-axis, so we go up 4, plot a point. Now I have to decide whether it's solid or dashed. It is a less than symbol, so we are going, so it's not equal to, so it's dashed. And then we are going to do a horizontal line because we decided it was a horizontal line. So it's dashed, and then because this one is horizontal, the same rules apply. Less than means we shade down. So everything under this line is part of our solution set. So again, the rules are decide if it's vertical or horizontal, plot the point at the number on the axis that goes with the letter, and then we draw in the horizontal line, make sure it's dashed or solid based on the sign, and shade appropriately. Let's do a different one. Okay, first we have to decide, is it vertical or horizontal? Well, y was horizontal, so x is vertical. We're going to plot a point at 1 on the x-axis. And now I have to decide whether it is solid or dashed. It's equal to, so it's solid, and we're going to draw in our solid vertical line. But because this is vertical, I can't shade above or below it. I have to decide whether to shade left or right. Everything that is to the left is less than that number. Everything to the right is greater than that number. So because it's greater than, we need to shade to the right. And there it is. There is our last problem. You have an assignment. If you have any questions, make sure to ask your math teacher. Please message us. We want to make sure that we help you however we can. And I hope it goes well. Sorry about the audio quality on this video. It looks like I need to do it a little bit differently in the future. But please let me know if you have any questions. Thanks, and bye.